Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to electricity in the chapter of AC voltage. This exercise was a previous one in the Brevet exams in 2006, first session, second exercise. The title of this exercise is Studying a Voltage Using an Oscilloscope. Our purpose is to study using an oscilloscope some characteristics of a voltage U delivered by a low frequency generator. Figure 1, number 1, they mentioned figure 1. Then now we can use it. Represents the waveform of the voltage U. The oscilloscope is adjusted as follows. The horizontal sensitivity is given by Vb is equal to 5 milliseconds per division. Knowing that millisecond is not the SI unit of time, in order to convert from millisecond to second, we divide by 1000. Then Vb, 5 divided by 1000, will give me 0.005 seconds per division, and the vertical sensitivity is given by 10 volts per division. Now notice that till this moment they didn't mention anything about figure 2, then we are not allowed to use it. Now the trick in solving such type of exercises is to determine the values of x and y, which represent the number of divisions along the x-axis and the y-axis respectively. So x represents the number of divisions between two consecutive peaks. Here, the peaks that we have, this is of negative value and this is of positive value. Then we cannot count the number of divisions between these two peaks because one of them is negative and one of them is positive. We need to count the number of divisions between two consecutive peaks. Either both are positive or negative. Then we will count the number of divisions along the x from the center. Then let's choose a point, skip a point and choose another point. And the number of divisions along the x-axis in this case is given by 1, 2, 3, 4, 5, 6, 7, 8. Then the value of x is given by 8 divisions. And y represent the number of divisions from the center to the maximum point reached by the waveform. So this is the center. The number of divisions is given by 1, 2, and 3. So y represent 3 divisions. Now in part A, they are telling me indicate the type of the voltage U, and indicate means we need to state with a justification. So this axis is labeled by time and this axis is labeled by the voltage U. So this voltage is varying with respect to time and it's negative and positive, and the shape is given by sinusoidal, so it's an AC sinusoidal voltage source. Then let's say since it varies with respect to time, and alternately positive and negative. Okay, between the brackets, the shape of this waveform is given by sinusoidal. Then the type of this voltage is given by AC. So let me say then it is an AC sinusoidal voltage source. Now in part B, they are telling me to calculate the period and the frequency of U. The period is given by Vb multiplied by x. Now the value of Vb in the SI is given by 0.005 seconds. So 0.005 multiplied by x, which represents the number of divisions along the x-axis. Plugging this on the calculator, it will give me 0.04. Since both Vb and x are in the SI, so the value of the period will be in the SI, which is seconds. Then the period is given by 0.04 seconds. Now in the same part, they are telling me to calculate the frequency, which is noted by small f, and we know that the frequency is given by 1 of the period. Now the period is given by 0.04. Plugging this fraction on the calculator, it will give me 25. Since the period is in the SI, then the value of f will be in the SI, which is given by Hertz. Then the value of f is given by 25 Hertz. Now in part C they are telling me to calculate the maximum voltage of U. The maximum voltage, which is the number of divisions multiplied by the scale, or in other words SV multiplied by Y. Now the value of SV is given by 10 volts per division, and the value of Y in this case is given by 3. This will give me 30. Since both SV and Y are in the SI, so the value of UM will be in the SI, which is volts. Then UM is equal to 30 volts. Now in the same part they are telling me deduce its effective value, and deduce means that we need to use the part just previously before. In this part we have determined the maximum voltage. We can deduce the effective voltage because we know that the effective voltage is defined to be the maximum voltage divided by square root of 2. Now the maximum voltage is given by 30. They didn't give me the value of square root of 2. Now plugging this fraction on the calculator, it will give me 21.21. Since the maximum voltage is in the SI, which is volts, then the value of U effective will be volts. So the effective voltage is given by 21.21 volts. Now in number 2, the generator G still delivers the same voltage U. We modify one of the two sensitivities of the oscilloscope. Here, before I continue, let me write here that the period is given by 0.04 second. Probably I will use it in this part. So the waveform of figure 2 is then obtained. They mentioned figure 2, then now we are allowed to use it. And as I said before, the trick in solving such type of exercises is to determine the values of X and Y before we solve. So here X represents the number of divisions between two consecutive peaks. So 1, 2, 3, 4. Then the value of X is given by 4 divisions. And the value of Y is the number of divisions reached, the number of divisions between the center and the maximum point reached by the waveform. So this is given by 1, 2, 3. So Y is given by 3 divisions. Let me make some space. Now in part A they are telling me indicate with a justification which of the two sensitivities VB or SV has been modified, and the word modified means that the value has changed. Okay, so now if you compare the two figures 1 and 2, we can notice that X has changed from 8 divisions to 4 divisions, while the value of Y remains constant to 3 divisions. And we know that the value of X is related to VB, whereas the value of Y is related to SV. Since the value of X has changed from 8 divisions to 4 divisions, this means that VB has been modified. Okay, so the scale or the sensitivity along the x-axis, which represents the time base or the horizontal sensitivity. Then let's say since the value of X has changed from 8 divisions to 4 divisions, then VB has been modified. Now in part B they are telling me to calculate the new value of the sensitivity, which represents VB, because now we know that VB has been modified, whereas SV remained the same, which is given by 10 volts per division. We know that VB and the period and X are related via the following formula. The period is equal to VB multiplied by X, knowing that we are interested in calculating VB. So constructing the triangle of this formula, here since we have multiplied, then the period will be at the top, VB and X at the bottom. We are interested in calculating the value of X, so the value of VB. Putting our hand over VB, then VB is given by the period divided by X. Here X represents the number of divisions of figure 2 and not figure 1. Now, knowing that the period didn't change because we didn't change the generator G or the settings of the generator G, which is given by 0.04, divided by the value of X, which is given by 4, plugging this on the calculator, it will give me 0.01. Since the period is in the SI and the value of X is in the SI, so the value of VB will be in the SI, knowing that the SI unit of the time base or the horizontal sensitivity is given by seconds per division and not milliseconds per division. So VB has been modified from 0.005 seconds per division to 0.01 seconds per division. Then now we have reached number 3. They are telling me we turn off the sweeping. What will be the shape of the displaced voltage U? Here, the sweeping is responsible for the motion of the waveform from left to right or right to left. So the sweeping is turned off. But knowing that the generator G still delivers the same voltage U, which is alternately positive and negative, whenever the sweeping is turned off, a luminous spot will be displayed either upward or downward, and this depends on the value of the voltage delivered by the generator. If it is positive, then it will be displaced upward. If it is negative, it will be displaced downward. Knowing that the generator G still delivers an AC sinusoidal voltage source, so this luminous spot will be displaced upward and downward, so it will represent a luminous segment along the vertical axis between a plus y and minus y. Then in this case, the oscilloscope will display a luminous segment along the vertical axis between plus y and minus y. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.